A few of you have had a very simple one-word question, and that question is torque. And I think you're wondering, in class I jumped right into torque and how to calculate it. Let's spend a little bit of time just reminding ourselves really basically what it is. And we're going to do that by thinking about two kinds of bottles. There's a bottle with a screw cap, and there are some bottles where it's held on by friction and you just pull the cap off. So most bottles are like this. These exist. I couldn't find one to bring here, but they exist, where you pull it off. So let's go, this kind of bottle is like the first 3 weeks of class. How do you get the lid off this bottle? You apply a force, right? We want to have it accelerate and move off the bottle, so we apply a force. You could draw the force here, and so you apply a force that way. Really, let's think real now to help us understand force and torque. You're really going to grab it with your hands, and you're going to pull it straight up. What you're really doing is you're using the muscles in your hands to create a large normal force. So here's your finger. You're going to create a large normal force, action-reaction pair, to create a large friction force. So that when you pull up, technically I guess it would be the static friction that you're applying to this bottle top. Okay? The details don't matter. All that really matters is you apply a force because you want the thing to accelerate up. Because we know that F equals ma. Sum of the forces equals ma. So that's the beginning, and I think that you're okay with. But then we got to get to torque. What is torque? So torque is really just the kind of force you apply when you want to turn something. So this kind of a bottle top has a screw on it, so to get it open, we don't just pull it up, we have to turn it. Okay? The detailed mechanism of why and why a screw is better, that's not the point of this. All we're thinking about is what kind of an action do we apply to get the lid off? We have to turn it. So think about this. In this case, you're also going to squeeze it to get a big normal force between your hand and the plastic surface, but then you don't pull up, do you? You rotate your hand. You actually, in this case, would push, if we want to turn it this way, you'd push with a force in here and out here. So the force is a completely different direction because you're not trying to lift it, you're just trying to turn it around an axis. Every time you think about a torque, it has to be around a certain axis. In this case, we're turning it around an axis going straight through the bottle. So we're applying a force around that axis. Out here, out in space, in front of the board, you'd be pushing it that way. And then inside the board, you'd be pushing it that way. So the torque is a force at a radius around an axis. To turn something, not just to accelerate it in one direction. So in terms of translation, this doesn't move it at all. Center of mass is in the exact same place. It doesn't translate it like this did, it just rotates it. And then the whole point of the last 2 weeks of class is the slightly different concepts in math of things that turn. Pretty much all the same equations, it's just there's little radiuses everywhere. Where it's not always the radius of a circle, but there's always the distance from the axis of rotation. So r here would be that distance and that distance. The big one, of course, is the new version of Newton's second law, which is that, well, of course, there's the sum, is that same sum, but of the torques, which is tau, equals I, which is the version of mass we talked about, where it's the mass and where the mass is relative to the axis. And then alpha, which is just the angular acceleration rather than the translational acceleration. So if you want to get back to the basic idea of a torque, think about the two ways to open two different kinds of bottles, straight up or turn.